Okay, mass, weight, and gravity. So let me make sure you've got these concepts down so you can make sense out of it. So we take a couple of shortcuts that show up, and you've already been using them, but we're going to make it a little bit more complex later on. Right now, just to make sure you have a few concepts down. So mass is the amount of material related to the amount of material that's present. So for example, here I have this guy holding a blue ball, another guy that's holding a big red ball. And those blue balls and red balls, right, they have some amount of mass, and mass is attracted to other mass. Right? So it does this through some sort of weird mechanism that's not really well understood, but we'll call it gravity. So we have two sets of objects, and they'll be attracted to each other. So mass doesn't change. So if you take that blue ball to someplace else, like a different planet, or put it next to another mass, right, that the amount of material there is still the same. So mass is independent of where it is. When we have a mass that's experiencing being next to another mass, it ends up having a force that it experiences, and that force we'll call here on the surface of the Earth, we call that gravity or weight. So let me be clear about how we do this. So a few things that are kind of important about this. So let me switch to a drawing. Let's go here. So again, we've been using some of this already, right? So you've seen us say, well, the force of gravity, this is equal to mg, right? And this is what that force, we're going to call this force due to gravity, this is weight. So sometimes we'll say something has a force of gravity, it has some weight, we put a W down in there, or we'll say mg, or force of gravity. All this is saying the same stuff, is that we have some mass that's experiencing a gravitational field from something else. Right? And be careful about this. So gravitational fields are all over the place. Right, right now you're in the middle of a gravitational field from the sun, but you don't feel it very much because it's pretty weak. So when we take a mass, and really the only way we have of seeing that there's a gravitational field is that we stick some mass there and say, oh look, it's attracted in that direction, so there must be some gravitational field. But notice that I need two masses for that, right? So two masses have to be attracted to each other. So we call this G, we call this acceleration due to gravity, but it also has another name. This is also the strength of the gravitational field that exists on the surface of the Earth. We're going to be careful about this, right? So this will be some acceleration that's experienced, right? But acceleration here on the surface of the Earth is also the strength of the gravitational field, and we'll have the units that are meters per second squared. Right? So a handy thing for us. So in this case, where we're dealing with masses that are experiencing the effect of gravity, this G is actually representing our gravitational field strength. Gravitational field strength. Right, so we could say here on Earth, what's the strength of our gravitational field? Well, it's 9.8 meters per second squared. Right? It sounds like acceleration, but it's not. It's both. It's both the gravitational field strength and the acceleration that you would experience if you put 1 kilogram there. So if we take this mass to someplace else, say to the moon, right, there will be a different gravitational field strength, and a mass would experience a different acceleration if it was present there. And so I forget what it is on the moon, maybe 6 meters per second squared. So it's a way of describing the gravitational field strength. So we'll use these a bit interchangeably, and it's important to recognize that while we have acceleration, we can have an object that might be accelerating down a ramp, and we'll describe that with meters per second squared, that we also have a gravitational field strength that we describe as meters per second squared as well. And in the event of free fall, those two things are the same value and they behave the same. So mg tells us a couple of things. This is going to tell us the force that thing is going to be experiencing, and from that we can get the gravitational field strength for here on the surface of the Earth. So we're going to separate things further, so we'll start looking at the gravitational field strength for things that are really far away. And the way that we do this is we say, well, what's the force that they're experiencing? And then we divide the mass out of this, right? So I can find my gravitational field strength. G is going to be what? It's going to be the force of gravity experienced divided by the mass. So we can do this, and we're going to come up with a more sophisticated way of calculating the force of gravity if we know the mass of the two masses that are involved. But again, gravitational field strength is something that is coincidental with acceleration, and we'll use that a bunch here. Anyway, I hope that's helpful. Talk to you soon. Bye.